Hi, welcome back to the CoEDL Summer School course for visualization. This is the third video tutorial following on from the introduction and the tutorial where we built a visualization of an interactive plot. In this visualization, we're going to build a comparison matrix that lets us do a systematic comparison of different pairs of values. And we're going to apply this visualization to two different data sets. The first data set that we're going to visualize builds on the data from the previous tutorial. So in the last tutorial, we built a visualization that compared consonant pairs in a sample of words in English and German. The data for this week compares whole languages by using that consonant pair comparison. So for the languages English and German, for example, it takes the average value of each of all across all of these consonant pairs in all of the words, and that comes up with a number between 0 and 100, where 0 would mean that none of the consonants were related, and 100 would mean all of the consonants in all of the words were the same. Now, the authors actually flip these values, invert these values, so subtract the average score from 100, and this gives a distance value. So the languages that score 0 have exactly the same consonants in all of the sampled words. And the languages that I've pulled from that same data source as last time are mostly European languages and languages close to that European side. So we can have a look in this data set. We have a property L1, which has the first language in each of our language pairs, and property L2, which has the second language. And then we have a value for the distance based on that consonant comparison measure, the distance between language 1 and language 2. And in the visualization, what we've done is create a square matrix or a table where the languages are arranged down the side and running left to right as well, and then where the languages meet. So if I hover over a square, we can see that this is the pair Dutch and German. And the value inside the cell shows the actual numerical score written down, and then we have a color scale ranging from dark blue, which is 0, to up in the close to 100, which is a bright yellow value. So I'm going to run things a little bit differently for this tutorial. Firstly, I'm just going to start by showing you what the finished specification looks like and talking through each chunk, explaining anything that's different or the same from how we built the Vega specification in tutorials 1 and 2. If you want to look over the specification in detail, you can go to the visualization notebook, which is at CoEDL Summer School Comparison Matrix Diagrams. And as always, the link to the workbook and the visualization will be in the description for this video tutorial. So if we look at the workbook page, we have a description of dataset 1, which I've just talked about, a description of a second dataset, which we're going to use in the same visualization, and I'm going to show you how we can adapt an existing visualization to display a new dataset. That dataset, which I'll talk about in a little bit, and then the spec 1, the specification for this first matrix, which we can see already, and then a blank specification for our second visualization and the cell for that visualization, and then some code down the bottom that lets us run our Vega dataset and import the data. So if we look at the finished specification for this visualization, we can see the normal properties are there: schema, width, height, something called padding, which is just creating some space around the plot. The title, data, signals, scales, axes, marks, and legends. Most of those we've seen before. Legends is what is used to create this legend or key over the side that's telling you what different color values correspond to in terms of the data values. So if we go back up to the top, we've seen width is 360, height is 320. Our title, we've just put the text there, and then we've used a property called anchor and told it to anchor at the start rather than the default value of the middle. And what that's doing is saying this title here should start over on the left of the plot. Our dataset has the name table, and it has some values, which are the array European, and if we scroll up we can see that cell European. So that's just that data of the L1 language, L2 language, and then the value. Our signals, just as last tutorial we did the selection, menu selection that let us change our word. This time we have a signal, has a name called Tooltip, because it's a tool that hovers over different elements in the plot, but we could have given it any name. This is just how we refer to it in the rest of the Vega specification. The initial value is just set to be empty, and then it has a property called on, which is an array that tells us a series of events and what the signal should do when that event happens. So the first event says when any rectangle mark has the mouse over it, we want to update the value of our signal tooltip by giving it the datum associated with that rectangle mark. Similarly, when any text has the mouse over, we want to update the tooltip with the datum associated with that text mark. Next pair, on any rectangle or any text, when the mouse goes out, so when the mouse moves away from that element, we're going to update the value of our tooltip to be a blank object again. So all that signal is doing is storing the data value of any element that we've hovered the mouse over. Our scales use the band scale that we saw in tutorial 2. So this is for ordered data, and it's arranging our X scale, our horizontal scale, is using the data field L1, so the first language in our data set, and it's ranging from one edge of the plot all the way to as wide as the plot. Has that padding value and a property called round true, which is just making a nice neat scale. And same with our Y scale, uses that band property, uses the domain of our field language 2 and our range of height. Then we have a new scale, which is a color scale, so I've named it C scale. It's using the type sequential, so this is a sequence of values, and the domain is going to be the data field value, so that was the score for each pair of languages that ranged from 0 for matching languages to 100 for very distant languages, and that was called value, so that's what has been assigned to the domain property. And we have the range, so this is telling Vega what color values should be assigned to those data values. We've given it the range heat map. So this is going to create a range of numbers from 0 to 100 and assign them to different colors ranging from cool colors, the dark blue, up to nice bright yellow colors. Then we have two axes. We have our axis on the left is just uses the same basic properties that we've used before. So that orient property tells it to go on the left, and the scale tells it which scale should be used to create the axes. For our X scale, we have a few additional properties, all about getting that label to be ordered in the right way. So if I delete them and press Shift Enter to rerun the plot, and we scroll down, we can see our languages are still there, but they're really hard to read because each label is running into the next one. So what the properties that we have back in our axes, let me find them, is say put the label angle, turn that to 270 degrees, so a 3/4 turn, label a line over to the right, so getting it to sit, so this is before we've done the angle transformation, so getting it to sit flush to the top of the plot, and label baseline to be in the middle. And if we press Shift Enter, then we can see they're flipped back around. Now the marks, the plot is built using two different marks. One is the rectangle mark that we used in the plots visualization, and one is the text mark that we used in the very first introductory tutorial. So both of these data marks, we can see for the rectangle, comes from the data table, which is the name we gave to our data set, and same, the text mark comes from the data table. And it's encoded using on the enter, so when the mark is first created, The rectangle mark has an X value that's set using the data property L2. So this is the horizontal position of the rectangle. Has a width, which is also set using the scale, and it's 1 band wide. This says however much horizontal space is assigned to a single value in our array, so assigned to each language, make the rectangle as wide as that band. The Y value, so the vertical position, is assigned using the field L1, the first language in the pair, and the height is again 1 band high. So it's 1 band wide, 1 band high, and that'll make the effect of being a 1 grid cell. If we changed the height of the property and made it a whole lot smaller, let's make it 120 pixels high, press Shift Enter, we can go down and we can see we still have a neat grid cell where each rectangle is just as wide as 1 language high, but all of the rectangles have shrunk uniformly. And so this is the power of assigning the width and height of a cell based on that scale formula, is that we can do a simple change of the plot dimensions and all of the visual shapes get resized automatically. So I just change it back to 320, then we get the much more readable and nice, closer to square shapes. So as well as the enter property, we've also assigned the rectangle some attributes on the update. So whenever the mark is updated, then we recalculate the fill. What color should that rectangle be? The reason we do this is so that we can use that signal that tells us whether a rectangle is being hovered over or not, and that signal is called Tooltip. So whenever the Tooltip has a value, it will be the data value of either the rectangle or the text that we're hovering over. So we do a test using this object. It's called test, has the property test, and this test is an expression that says, is the datum dot L1, so is the L1 value of the mark that we're currently encoding equal, and the double equal sign is used in JavaScript logic operations, equal to the signal datum language 1, or is the L2 of the datum, that is the mark that we're currently encoding, equal to the tooltip L2 value. And if they are equal, then we're going to set the value to this kind of warm red color, which is called Indian red. And so what that's saying is, if the first language is equal to the language of the value we're hovering over, or the second language is equal to the value we're hovering over, color that's rectangle red. So these double lines are the JavaScript OR operator. If we just delete what's after there and run the cell again, pressing Shift Enter, this time we're just getting the language 1 matches. So things that match along the vertical axis. If we go back up, undo. If we cut out the first part of the test instead, press Shift Enter, we're just getting the vertical matches. If we say matching L1 or matching L2, then we get both lines. So this test operator, which is inside an array value, it works by saying, firstly, do a test, then you have a comma. If the test is true, Vega will use this value you put inside that object. And then after that object, we put another comma and then we say, what should we do if the data doesn't pass that test? So in this case, we're going to use our color scale and we're going to use our data field value. That says if we have no data that's hovered over, everything is going to get assigned the color scale. And if we're hovering over anything, then anything that we're not hovered over and that's not equal to the L1 or L2 value is going to get the rectangle filled based on the color scale that we've defined. So in the text mark, it's again from that data with the name table. It's encoded only on the enter. We're not updating the text at any point. And the horizontal position is set using that X scale and the field L2. The Y value is set using the Y scale and the value L1. Both of these we've put an offset, which just neatens up the text position. So if I delete this offset and press Shift Enter, we can see it's just hitting on the start of where the rectangle starts. So if I undo that, press Shift Enter again, the offset just moves it across that many pixels, so 12 pixels. We're aligning and changing the baseline of the text. So we've done before, and we're filling it white, and then all important, assigning it the property text, which says what value should be printed inside each cell, which is the data field value. And then the final property that we have in our Vega specification is the property legends, which, as I said, creates this color scale over on the right. This has a title which describes what that color value means to the reader, and the fill is set using that color scale that we defined earlier, C scale, and we give it a type. So in this case, our type is a gradient because it runs a linear span of values. And so that's how this comparison matrix is created. I encourage you to play around with any parts of the visualization that you aren't sure about. Just try deleting different properties, pressing Shift Enter, see whether it still runs, see whether anything in the visualization has changed. Or changing the type of scale of the values, doing a new test in this update property, or trying out whether you can get the text value to change based on the hovered over property using our signal tooltip and using this update property in the encode phase of mark creation. One of the things that we often want to do in visualization is take an existing visualization and apply it to a new data set. So I'm going to talk through how we'll do that with this visualization. The data set that we're going to use is some data set from a Nature paper on the origin and expansion of Pamangungan languages across Australia. And the data in this paper looks at cognates from 306 Australian languages grouped into 31 subgroups. You can see the data that we're going to be plugging into our visualization just below this explanation. It's got the L1 value, L2 value, and a value called matches. It's also got a value called words, which we're not actually going to use in our visualization. So the L1 and L2 values, in contrast to our previous data set, these aren't languages, these are language subgroups. And our matches value is looking across the cognate sample that the authors found and looking at each of the languages in the subgroups and seeing, are there any words with the same gloss that are used in some of the languages in the L1 subgroup and in the languages in the L2 subgroup. For example, the word, apologies for my pronunciation, Kankani means above in both Nyangamata in the Marangu subgroup and Kuruma in the Ngyata subgroup. So that means when we come across that match, we add 1 to the matches value of the Nyangata subgroup and the Marangu subgroup pair. And this value for this particular pair is 19 because we have 19 different words with the same gloss that match in at least one of the languages in each of those pairs. And if we scroll down and keep clicking more on this data array, we can eventually find a pair of language subgroups which have a lot of matches. And then if you open that up and have a look at the words, you can see which words have actually matched. So I'll just close that data set up. So what we're going to do is we're going to try and plug this data into our visualization, our Vega specification, generate the visualization, and then have a look at how the Pamangungan subgroups compare to each other, the same way that we could look at when European languages. So firstly, we're just going to copy the whole of the Vega specification. So I'm just going to go Control A, Control or Command if you're using a Mac, Control copy, and going down to our cell spec 2, just going to delete what's in there, copy all of that in, and change the name back to spec 2. Press Shift Enter. We have our specification in there. We've just regenerated our European language comparison, and that's because this data value that we're still using is still our European value. So instead, I'm going to put in the name of our Palming Union subgroup matrix, and this is PN underscore subgroups. So I'm going to change it to capital PN underscore subgroups. You can see it's changed dark blue because observables recognizing that that is the value of a variable in our notebook. Press Shift Enter. Scroll down, and what we'll see is we've got the names of all of our subgroups appearing, and they've actually appeared twice, but we don't have any values. And if we have a look back up at the data set, that's because we don't have a data property called value, which was how we were encoding the rectangle color and the text name. Instead, we have a property matches. So what we're going to do is we're going to go to our second specification, and we're going to replace anywhere we see the property value, we're going to replace it with the term matches. So I'm just going to search for the value. So we're looking for things where it's the data table and the field value, and I'll replace it with the field matches. Find it again. This is going to be, that first one's telling us the color value to use. Instead, I want to look where we're using the data field matches. Data field value changed to matches. It's just describing our legend. Okay. So I think that's everything. Press Shift Enter. And we can see we have values coming in here. Now, this is a lot harder to read because we have a lot more language subgroups than we have languages. So if we just make the visualization a bit bigger, I'll make it 560 and 520, Shift Enter, then we can see suddenly it's more readable. We still have a problem that our text is it's been offset too far now based on our current size of our data. So we'll take that down to about 8 and we'll try 4. This is in our text mark. The X and Y values, changing the offset a bit, and that's nicely in the center. Now, the other difference between our matches and value is our European languages. When we compared a pair of languages, if they had the value 0, that meant the languages were close. In our matches value, a value of 0 means we've got no matches. So we're currently telling the reader the wrong thing with our label of our color scale. It's currently saying that a low value says the languages are similar. Actually, what we want to say is that a low value means no matches, or the value means the number of matches. And we also have to change the title. We're just going to change the title so that it says matching words between subgroups of Palming Union languages. Shift Enter. So now we have a plot that's displaying our data and describing it correctly to the reader. It's telling us that our number of our color scale corresponds to the number of matching words between the pair of subgroups. If we hover over any cell, we can easily find out which pair of language subgroups that we're looking at and isolate those values. In my version of the visualization, which you can get to by following the link at the top of this workbook or by following the links in the description of this YouTube video, you can see I've made a whole lot of just aesthetic changes to the visualization that make it easier for us to find values where those subgroups have many more matches than is typical. So if you want to have a look at the specification that I've used and compare it to the one that we've just defined by copying and pasting from our European language comparison and see what's different and see how those simple aesthetic changes have been created in Vega. And if you're coming to the summer school in person, I'm going to be talking about why those changes in particular make the visualization easier to read. In the next tutorial that we're going to do, I'm going to again look at this subgroup data and have a look at the geographic location of the different subgroups and let us see how these matches, word matches, correspond or differ based on geographic region. Until then, play around with Vega and Observable and stay tuned for more developments by subscribing to this YouTube channel. Bye for now.